In this lesson, we're going to start looking at some 3D problems that involve density. So the first thing you need to recall is what is density. So density is something that you've talked about in science class, and it's a measure of how much mass is located within a specific volume of space. So that means your formula is mass per volume is equal to the density. So now this is something that you've seen before. So D equals m over v, so it's the weight or the mass per volume. Another thing that you might have seen is it located in a triangle to kind of help you remember the formula. So D equals m over v. This can help with calculations, and we'll talk about it. But it's basically the same as the formula. You have your density and then you have your mass divided by your volume. So if I'm trying to find density, I can block out the D and it means m over v is my calculation. But if I'm trying to find m, I can block out the m, and that means my calculation is density times volume. So it's the same thing as using this formula and cross multiplying and solving, but this triangle is kind of just a shortcut. So one thing though that you do have to know is this formula. It is not given to you on your reference sheet, so you must memorize the density formula. So it's something that you have to know. So looking at this first scenario, it says that these two objects, and you can kind of see in the picture here, we have a brick and a sponge, and they have approximately the same volume. So the length, the width, and the height is approximately the same. But in water, the sponge will float and the brick will sink. And the reason why is because their densities are much different. So the density of a sponge is much less than the density of a brick, and the density of a sponge is less than that of the water, where the density of the brick is more than the density of the water, therefore it'll sink. So to kind of sum it up, the density of the sponge is less than the density of the brick. And again, when you compare those to water, the sponge has less than the density of water, and the brick has a density greater than that of the water. So think about it in terms of the weight per volume. So looking at an example, this next example, where we're going to actually be calculating the density. So we have a block of butter that weighs 200 grams. So this is the mass. The dimensions are 8 centimeters by 5 by 6 centimeters. What is the density to the nearest thousandth? So when you're looking at this, the units are going to be what's really going to help you decipher what's given to you in the problem. So if you're given some kind of weight measurement, so grams, kilograms, pounds, tons, those are all going to represent mass. If you're given linear measurements or length, centimeters, inches, feet, meters, those are all going to be what's going to end up giving you the volume, because you're going to have cubic units. So centimeters cubed, feet cubed, inches cubed, that's always going to represent the volume. Your density always has to be a mass per volume, meaning it's going to be some kind of gram over cubic centimeters or kilograms over cubic meters. So it's always going to be some kind of mass divided by volume, which is where the formula comes from. So that's kind of how you can decipher which thing is given to you. So this right here is going to allow me to find the volume. A block of butter is a rectangular prism. So we have this block or stick of butter, and my dimensions of this are, I'm going to say that this is the 8 centimeters according to my picture. I'll say that this is the 5 centimeters and this is the 6 centimeters. It doesn't really matter. So the volume of this is length times width times height. So volume equals 5 times 8 times 6. So I'm going to go ahead and multiply those. So 5 times 8 times 6 is going to give me 240. And units here are going to be so important to make sure you're labeling. So this is going to be centimeters cubed. So the whole reason why I care about the volume is because I'm trying to find the density, and we know that density is mass over volume. Or if you're thinking about the triangle, density, mass over volume. So if I'm trying to find the density, cover that up, what are you left with? M over V. So that means now that I know my density, or I know my volume and I know my mass, to find the density, it's really simple. You're just going to divide it. So you're going to take your mass, 200 grams, and you're going to divide that by the volume, centimeters cubed. And we're going to go ahead and we're going to round that to the nearest thousandth. So 3 decimal places. So 200 divided by 240. So when I round that to the nearest thousandth, it's going to be 0.833, because the 3's are repeating. I'm going to make that approximately equal since I'm rounding. Notice my units here, grams per cubic centimeter. So it's a mass per volume. So my units have to represent that. So that, again, like I said, you look for that type of unit, a mass per volume. That's going to be your density. That's how you're going to identify the density in a problem. So the next little piece here in your notes, that's just the portion of the high school reference sheet that you guys will have given to you on all exams, including the Regents. And that just gives you some conversions that might not be as well known. So this is just something to keep in mind, and we're going to actually use it for this next problem. So let's go ahead and read through this next problem. So in the movie Raiders of the Lost Ark, archaeologist Indiana Jones replaces a solid gold idol. So we're going to replace a solid gold idol with a bag of sand. The idol rested on a platform which precisely counterbalanced the temple's ancient self-destruct mechanism. The idol can be modeled by a cylinder. So this golden idol can be modeled by a cylinder with a height of 18 centimeters and a radius of 6 centimeters. That's going to be important. We also know the density of gold. Notice the units here, grams per cubic centimeters, so a mass per volume. And then we also know the density of the sand. So we want to know what was the mass or the weight of the idol in pounds. Now remember, the idol is the solid gold. So that means I'm going to care about the density of the gold, not the density of the sand for this particular part of the problem. And I also know that the idol can be modeled with a cylinder using a height of 18 and a radius of 6. So that's going to be important. So if I want to find the weight, this is a common scenario that you're going to see in geometry. You're going to be given a density typically. You won't always be finding the density. Typically, they'll give you the density. You know how to calculate the volume because that's what we've been doing in this entire unit so far. And your goal will typically be to find the weight. So they'll give you the density typically. You'll find the volume. You'll use those to find the mass. So if you think about our density formula, D equals M over V, or you can use your triangle to kind of help you here. So I have density equals mass over volume. If I'm trying to find the mass, which is what I'm trying to do here, that really means I'm going to be, so if you kind of imagine covering that up, it means that mass is really going to equal density times volume. So this is really what I care about. So again, I covered that up, and then I looked at these are next to each other, so it's multiplication. Versus if I covered up the density, M is over V, so it's division. You could have also just looked at this and cross-multiplied. Mass is equal to density times volume. So my goal here is to be able to find the mass, which means I need to know the density and I need to know the volume. Well, luckily, I have the density given to me, and I am trying to find the mass, and I can easily find the volume. Now what I'm looking at here is my units. My units are going to kind of be an issue because your density is really going to kind of tell you what you need your units to be. So if I look at my units, I have grams per cubic centimeters, and I want my answer to be in pounds. So what that means is when I go to find my original mass, and if I'm using grams and cubic centimeters, I'm going to then have to convert my final answer into pounds. The good news is my dimensions of my cylinder are already in centimeters, and I need them to be in cubic centimeters. So that's good. So we don't have to worry about that, but in the end, we will have to do a conversion. So kind of looking ahead, I'm aware that there's going to be a conversion. So the first thing I'm going to do is I'm going to find the volume. So let's get our volume formula. So volume is pi r squared times h for a cylinder. So again, we have our cylinder. The height of this is 18 centimeters. The radius is 6. So this is a straightforward just plugging in. So we have pi times 6 squared times 18. I'm going to leave this in terms of pi because this is just the beginning of this problem. I do not want to round until the very end. So when I leave that in terms of pi, I'm getting 648 pi. Again, units are so important here to make sure you're keeping everything straight. So 648 pi cubic centimeters. The next thing is going to be to go ahead and plug into my mass. So I'm going to find the mass. So the mass is going to be the density, 19.32. Again, being very careful with those units. Grams per centimeters cubed times 648 pi cubic centimeters. So now what happens when I multiply these cubic centimeters are going to cross right off or cancel out because it's basically cubic centimeters divided by cubic centimeters, so it just becomes a 1, so those are gone. So that means my final unit here when I multiply these is going to be in grams. I'm not going to put pi in my calculator because, again, I want to leave this as accurate as possible to the very end. So 19.32 times the 648 is what I'm entering, and I end up with 12,519.36 pi. And again, this is going to be in grams because of that unit right there. So my cubic centimeters canceled. So now I have to worry about this conversion. So I get the mass in grams, but the question asks for it in pounds. So let's take a look at our reference sheet because I'm guessing you don't know the conversion. I don't know the conversion between grams and pounds. It's not something that's well known. So if we look at our conversion sheet, we have some different scenarios that are dealing with pounds. So here are different scenarios. I notice that I have two that might be helpful. And the reason why I say these two might be helpful is because they're comparing pounds to kilograms. And if I know grams, it's much easier to go to kilograms than to try to go to ounces or tons. So that's why I'm picking these. So if you, there's a couple different ways the conversion between grams and kilograms, that's the way I need to start. And then what I'm going to do once I get kilograms, well, then I'm just going to say, well, if 1 kilogram is 2.2 pounds, that's going to help me get my pounds. So the first thing we need to do is we need to get to kilograms so that I can actually use that conversion. So let me take this. So I'm going to say step 3, we're going to deal with our conversions here. So the first thing I need to do is grams to kilograms. So your conversion for this is 1 kilogram is equal to 1,000 grams. So hopefully that's something that you remember from science. I will talk a little bit more about this in class, but there is an acronym. I don't know if you have heard it, but King Henry died unusually drinking chocolate milk. This is just an acronym to help you remember your conversions. The U stands for units. K stands for kilo. So if I'm going from grams to kilograms, I have to go backwards 3 places. So that means I'm going to be taking this and I'm really going backwards, or I'm going to the left 3 places, which really means you're dividing by 1,000. So you're moving your decimal 3 places to the left or dividing by 1,000. So that's one way to convert. The other way is looking at your unit conversion. You can write this out. Take your grams. So I have the 12,519.36 pi grams. I'm trying to cancel out grams. So taking my conversion factor, the grams would go on the bottom because I'm trying to cancel that out. 1 kilogram stays on top. Cancel out the grams. So essentially multiply across the top, multiply across the bottom. This is really over 1. and I end up just dividing. So either way, when you divide, you're just moving that decimal 3 places to the left. I am not doing anything with pi. I'm just keeping pi in my answer for right now. So there's my kilogram conversion. The next thing is to use the conversion from the chart, which is going from kilograms to pounds. And that conversion, I got to go back up to the chart here. 1 kilogram is 2.2 pounds. So 1 kilogram equals 2.2 pounds. So if I take what's given to me here, this 12.51936 pi, don't forget about that pi, kilograms, I'm trying to cancel out the kilograms. So that's going to go on the bottom because I want to cancel those units out. The 2.2 pounds will go on top. So essentially you're multiplying. And when you do this, so let's type this in. This time I'm going to go ahead and put the pi in my calculator. So I have 12.51936 pi. And I'm going to times that by 2.2 because these kilograms are canceling. And that leaves me with 86.5276, so on. That's in pounds, so that means the question doesn't tell us how to round, but I'm going to go ahead and say to the nearest pound, just for the sake of this problem. It should say, and it doesn't. So that means I'm going to say approximately 87 pounds is the weight of that gold. So there's the very first part of this. So then the next part is on the next page. So let's go ahead to the next page here. And what was the needed volume of sand to avoid tripping the self-destruct mechanism in cubic centimeters? So what we know so far, we know the density of the sand from the previous page, so let me go back and just write that down. So the density of the sand is 1.6, so 1.6 grams per cubic centimeters. So there's the density of the sand. And we know that the weight of the gold figure is approximately 87 pounds. So what that means is we need to make sure that the sand with this density is going to weigh that much. So we want to, if you think about your density formula, we'll know the mass because we know what the mass should be so that the trigger thinks it's gold, and we know the density, so we're going to use that to solve for volume. So if I think about my rule here, density equals mass over volume. If I'm solving for volume, that means volume is really equal to mass divided by density. So that's what I'm going to solve for. Now, if you notice my conversions here, I have grams and I have cubic centimeters. I'm going to be able to solve for my volume in cubic centimeters, but I need my mass to be in grams because it needs to match that density. So instead of using the 87 pounds, I'm going to actually go back to when I had this gold in grams. I actually want that, and then that way I can actually use the exact value because that was before we converted it. So in grams we had 12,519.36 pi. That's what we had from the previous problem. So this is what I'm going to use. So I'm going to use these two things and plug in. So the volume is going to be the mass, so the 12,519.36 pi grams divided by the density, 1.6. This is grams per cubic centimeter. So what's going to happen here is the grams are going to cancel. We're going to type that in our calculator. So I'm typing in that exact value there, including pi, because I want to get a final answer. So I'm going to divide that by 1.6. This is giving me 24,581.7 058, I'm just going to say, and so on. Again, I'm going to round this to the nearest cubic centimeter, so nearest whole number. So that means the volume is going to be approximately 24,582 cubic centimeters. To think that that sand is really the weight of the gold. So that's kind of how I figured that out using the density. So go ahead and check your understanding problems, get a key idea, and we will talk more about this in class tomorrow.